Before we do today's notes, I wanted to share with you my work environment. So you can see I got a nice view of my neighbor's property. I got all my plants ready for spring planting, growing up nice. I got a pile of lab books I got to grade. And then I got a great view of the outside where every once in a while I get a nice bird, bluebirds, cardinals, and things landing right outside my window. Anyway, here are today's notes.
Okay, today we're going to learn about Ohm's Law. Yesterday you did a lab on Ohm's Law. Unfortunately, we had to do it in the virtual world, but all of you got pretty good data. Today I'd like to go over that lab and see how it connects with all the terms we've learned for electricity. Okay, I want to start with our independent variables. These are the things that we control. We control the resistance of our object. So for a light bulb, we control what the wire is made out of inside the light bulb. We control how thick the wire is, and we also control how long the wire is. So this resistance is determined when they make the bulb. We also control the voltage of the battery. We control that again when we make the battery based on what chemicals we put in the battery, what the metals are for the electrodes. Once we have these two independent variables, we can now calculate our dependent variable, and that will be our current. We pick resistance, we pick voltage, nature determines the current. In lab, the first thing we did is we kept our resistance constant and we changed the voltage of our battery. You cycled through like 8 different batteries and all of you found a nice proportional relationship. You got some kind of number, I equals some number times voltage, and that number that you got here is somehow related to the resistance that you used. The next part, you change the resistance, leaving the battery in place, and this time you got an inverse graph. You found that more resistance caused there to be less current. Hopefully this is very logical. Resistance tells you how hard it is for the electrons to flow, so more resistance would cause less current. The equation that we get from this lab is that the current is equal to the voltage divided by the resistance. When you did part 2 and you got your equation, hopefully you noticed that this number was very close to the voltage of your battery. When we did part 1, you might not have realized that this number is the reciprocal of your resistance. So in both cases, we get I equals V divided by R. Okay, we can also look at this equation, I equals V over R, in a slightly rearranged form. So we're going to swap the places of the I and the R by cross multiplying. And we can see that resistance is actually voltage divided by current. What that means is that ohms is actually a measure of voltage divided by amps. What that means is that if you have 15 ohms, like for this resistor, it means that it would require 15 volts to create 1 amp. So ohms tells you volts per 1 amp. So if you had a 200 ohm resistor, that resistor would take 200 volts to make 1 amp go through it. Okay, so just to recap all the things we've learned, when you have a wire, the resistance of the wire depends on what the wire is made out of, how long the wire is, and the area of a cross-section of that wire. We already know the formula to calculate that resistance. We then combine that formula with the voltage of the battery, and that will let us figure out how much current is going to come out of our battery. Once we know the current coming out of our battery, we can then figure out how much power we're going to get from our light bulb. Now, power is probably our most important thing. The power is going to determine how bright the light is. It's going to determine how loud a speaker is. It's going to determine how fast a motor is. It's going to determine how hot we can make something with something like a hot plate. So getting the power, just to recap, you first have to find the current. You find the current by using Ohm's Law. You find the resistance using the formula for resistance. So this would come first, this would come second, this would come third, and this, again, is our most important equation. I want you to try one of these. So I'm going to give you a light bulb. I'm going to tell you the resistivity, so you don't have to look on your purple sheet. I'd like you to figure out the resistance of this bulb. Once you have the resistance, you're going to hook it up to a 120 volt outlet, and I'd like you to figure out the current that goes through the bulb. Once you got the current, I then want you to find the power of the bulb. Once you have the power of the bulb, I want you to figure out how much it would cost to run that light bulb for 8 hours a day for a full 365 day year. Okay, and that's all I'd like you to do for today. Make sure you put all your work and all your notes on the slideshow, just like you've been doing for everything else.